Hello and welcome back to Chandra Shekher Research Academy of Business Studies. In today's video, we're going to discuss large sample tests, focusing specifically on the mean test for the difference between two means. Let's dive right in. The mean test is used to determine whether there is a significant difference between the means of two large independent samples. Let's start with the null hypothesis, which is denoted as mu1 equals mu2. This means there is no difference between the population means. The alternative hypothesis depends on the research problem and could be one of the following: mu1 not equal to mu2. This is for a two-tailed test. Mu1 greater than mu2. This is for a right-tailed test. Mu1 less than mu2. This is for a left-tailed test. The test statistic we use is called the Z-statistic, and it is calculated using the following formula: Z equals open parenthesis, x1 bar minus x2 bar, close parenthesis, divided by the square root of open parenthesis, sigma 1 square divided by n1, close parenthesis, plus open parenthesis, sigma 2 square divided by n2 close parenthesis. Let's break this formula down step by step. X1 bar and x2 bar are the sample means of the two groups. Sigma 1 square and sigma 2 square are the variances of the two populations. N1 and N2 represent the sample sizes of the two groups. Before applying this formula, there are a few important assumptions to keep in mind. The two samples must be independent of each other. Both sample sizes should be large, typically greater than 30. The populations should follow a normal distribution, or the sample sizes should be large enough to satisfy the central limit theorem. Now let's discuss the steps to conduct this test. Step 1. State the hypotheses. The null hypothesis is mu1 equals mu2, and the alternative hypothesis is based on the research problem. Step 2. Choose the significance level, denoted as alpha. Common choices are 0.05 or 0.01. Step 3. Calculate the Z-statistic using the formula. Z equals open parenthesis, x1 bar minus x2 bar, close parenthesis divided by the square root of open parenthesis sigma 1 square divided by n1 close parenthesis plus open parenthesis sigma 2 square divided by n2 close parenthesis. Step 4. Determine the critical value using a Z-table. For a two-tailed test, use plus or minus Z alpha by 2. For a one-tailed test, use Z alpha. Step 5. Apply the decision rule. If the absolute value of Z is greater than the critical value, reject the null hypothesis. Otherwise, do not reject the null hypothesis. Step 6. Write the conclusion. State whether there is enough evidence to support a significant difference between the means. Let's look at an example. Suppose we have the following data. Sample 1 has a mean of 100, a variance of 15 square, and a sample size of 40. Sample 2 has a mean of 95, a variance of 20 square, and a sample size of 50. We use the formula Z equals open parenthesis, 100 minus 95 close parenthesis, divided by the square root of open parenthesis, 15 square divided by 40 close parenthesis, plus open parenthesis, 20 square divided by 50 close parenthesis. First, calculate the variances divided by their respective sample sizes. 15 square divided by 40 equals 225 divided by 40, which is 5.625. 20 square divided by 50 equals 400 divided by 50, which is 8. Next, add these values. 5.625 plus 8 equals 13.625. Now take the square root of 13.625, which is approximately 3.69. Finally, calculate the Z-statistic. Z equals 5 divided by 3.69, which is approximately 1.355. At a significance level of 0.05 for a two-tailed test, the critical value is plus or minus 1.96. Since the absolute value of 1.355 is less than 1.96, we fail to reject the null hypothesis. Conclusion: there is no significant difference between the two sample means at the 5% significance level, and that's how you conduct a large sample mean test to compare the difference between two means. If you found this video helpful, please like, share, and subscribe to Chandra Shekher Research Academy of Business Studies. Until next time, keep learning and stay curious.